Hello guys, welcome to my final project presentation. I'm Dennis Muriungi from Kenya. I am a machine learning engineer based in Kenya. So my project was on model quantization. So the objective of this project was the first objective is to understand how model quantization is done, and the second one is to understand transfer running using MobileNet v2. The third objective is to perform model quantization using post-training quantization, and the last one is to perform model quantization using quantization-aware training. So let's talk through what we'll cover in this presentation. So in this presentation, I'll cover the definition of quantization. This will help you know what is quantization. You also discuss the importance of quantization. Then you move on to model quantization using Kagoshu dataset. Then we perform data augmentation on our dataset. Then number 6, we do transfer running using MobileNet v2. Then we train the model using post-training quantization. Then we retrain the model using quantization-aware training. So let's get started. First of all, what is model quantization? Model quantization includes conversion technique used for performing computation and storing tensors at 1 between and floating point precision. For example, instead of using 32-bit floating point numbers to represent the parameters of a neural network, you might use 8-bit integers. Basically, we have two types of model quantization. The first one is post-training quantization. In this type of quantization, works by the virtue of reducing the size of a model, thereby improving the CPU latency. And the second quantization is quantization-aware training. This type of quantization emulates inference time. It emulates the inference time quantization by creating a model that downstream tools that to produce a quantized model. So let us move on to the importances of model quantization. First of all, model quantization is important because it helps us improve the computation efficiency, especially when deploying models on resource-constrained devices such as smartphones. And the second importance is that quantization helps us overcome sparsity in networks by reducing the amount of memory required to store and process the model. And the third importance is that quantization helps us run ML models, machine learning models, on small devices like Raspberry Pi. And the last importance is that quantization can help run models on device rather than on cloud. And we all know that running machine learning models in the cloud is very costly. So quantization can help cut this cost when models are deployed and run on device rather than on cloud. So for my project, I used the shoe classification dataset on Kaggle. In case you're interested in this dataset, I will share the link. I have included the link in my presentation. You can access it. You can access it over here. So for this project, we will begin for the quantization project. So I begin by importing the required library. For example, simple libraries like NumPy, Pandas, and then Pandas. Then there are other libraries which I use include Tensorflow, which is a library used for training, building, and deploying ML models. Also, I use the image generator class, the image data generator class, which is a utility in the TF graph resourcing.image module. The image data generator class is an utility of the TF.class preprocessing.image module on the Tensorflow and allow users to easily apply augmentation to image data. It takes in a set of data augmentation parameters and applies them to another set of images, generating a new augmented dataset that can be used for training machine learning models. Generally, this class helps us to apply augmentation on our data. So also you will require in this notebook, I have set the 16 times 8 quantization mode. First of all, you have to check if the 16 times 8 bit quantization mode, you have to check if the 16 times 8 quantization mode is set. So you use this line of tf.write the tf.write offset experimental tf-write building activation there, this one. Then we can go on and run our data. So let's talk about data augmentation. So basically, data augmentation is a technique used to artificially increase the size of dataset by generating a modified version of for the existing data. This can be useful for training machine learning models, as it can help prevent overfitting and improve generalization. In this notebook, you will use image augmentation technique, which is help us applying transformations such as cropping, rotating, scaling, and flipping of images. This in return will help us to improve the performance of our model by providing additional training data that helps the model learn more robust features. So we will declare some augmentation parameters, which in turn we will use in our training model. To learn more about data augmentation, you can visit this page. I will also share the link to my notebook so that you can view how I performed quantization. So this is the point that we will use to perform augmentation with. So basically here the random flip, it will randomly flip the images horizontally, and the random rotation, here it will randomly rotate the images in this to this ratio, and the random zoom will randomly zoom images to a ratio of 0.1. So to run our data set test, here we will create an image data generator object and use it to run the training and testing data. The flow from directory method of the image data generator class reads the images from the specified directory, resizes them to the specified image size, and return a generator that can be used to iterate over the data. You can use the train generator and test generator object to feed the data to a model during training and evaluation. So this is the point which is used for running the data. So you can see we have 1000 files belonging to 5 classes in the train data set, and in the test validation data set you can see we have 2500 files belonging to 5 classes. And these classes are the classes which are found in this data set. These classes are mallet, flat, boat, block, rock, sneaker. So basically in machine learning here we will be predicting if our model accurately predict these classes if they belong to If it is a certain shoe, if that shoe, for example, is ballet flats, boots, bra, crocs, sneaker, like that. So let's visualize our shoe images before performing data augmentation. So this is how the shoe dataset looks, the images looks. You can see we have not yet performed augmentation on the shoe images. You can see the images are just normally as the way they were. No rotations, no zoom, no random flip. So let's see after doing augmentation how our dataset look like. So let's visualize the augmented dataset. So after performing the augmentation, you can see augmentation prompts the way they are. For example, randomly flip the images. For example, this you can see they have rotated, can be rotated, zoomed. So our model will be able to run more robust features from this kind of augmented dataset. So the next step is perform transfer running using MobileNet v2. So MobileNet for the base model, you will use the pf class.application.mobilenet v2 mode. This mode expects pixel value in the range of -1 to 1, but the pixel range of our images is 0 to 255. This is how we will scale them using the pre-processing method. In this case, we will use the pf class application MobileNet v2 function from a pf class application module. The function returns a pre-trained MobileNet v2 model that you can use for various tasks such as image classification, object detection. This will download the MobileNet v2 model and do it from the internet and create a MobileNet v2 model object that you can use for your task. By default, the MobileNet v2 function runs the model with the weight trained on the ImageNet dataset, which consists of about 1.4 million images and 1000 classes. So you can see this image this is a very large dataset which consists of 1.4 million images and 100 classes. So this tells us that this pre-trained model of MobileNet v2 can help us train our model using transfer running, because as you can see, this model has been trained on 1.4 million images and 100 classes. So now let's get the base model of a pre-trained model convert. To do this, we will first pick a layer of MobileNet v2 which we will use for feature extraction. We will depend on the last layer before the flatten operation system. Very last classification layer is not considered useful. This layer is called the bottleneck layer. For those who are familiar with the PyTorch UNet model, I think you are familiar with the bottleneck layer. So this is the code we use to run our the MobileNet v2 model. You can see the layer of that of ImageNet. So after loading our model, now you perform feature extraction. First of all, you freeze the convolution base created from the previous step and use it as a feature extractor. Then we will add a classifier on top of it and train the top level classifier. We then freeze the convolution base to help prevent the weights in a given layer from being updated during training. So this is the architecture of our model. This is how the architecture of our model looks like. So now you continue to build our model. You continue to build our model by chaining together the data augmentation, the scaling based model and feature extractor layers using the keras function API. Then you use the training force flag as our model contain batch normalization there. So we set the force flag because our model contains the batch normalization there. So now let's train our model. This is the code used to train our model. I use 10 epochs to train the model. So you can see after training the model without performing quantization, we got an accuracy of 0.9815, which is a 98% accuracy. Here is the visualization of the accuracy and the losses of our model. Now let's move on to training our model. Training the model now using post-training quantization. To train our model using post-training quantization, you will create a TF-lite converter object from the keras model using the tf.write TF-lite converter keras model. You then set the optimization mode of the converter to default, which enables post-training quantization. So here, by setting optimization mode of our converter to default, this automatically enables post-training quantization, which is achieved by using this piece of code. Converter.optimization equals tf.write optimization default. So this is how we set our converter to default for post-training quantization. The mode is then converted to a TF-lite model, and then we save the model. Once our Tensorflow model is saved, we can now deploy it on a mobile device and use it to make predictions on mobile devices. So let's move to the second quantization. The next type of quantization, which is quantization aware training. So in this type of quantization, we will first of all create a function called apply quantization to dense layers. So basically what this function does, the apply quantization to dense layers function, the function takes the layer as the input and return a quantized and untized layer. So after training the model with quantization aware training, let me show you in my notebook. So you can see after training our model with quantization aware training, our accuracy rose from 0.98 to 0.9941, which is 99%. So this was 0.9815 to 0.945, which you can say it is an improvement. So you can see that quantization aware training can also help us improve the accuracy of our model for for small devices. So generally, to conclude, generally post-training quantization can be a useful technique for reducing the size and complexity of a machine learning model. While quantization and training can be used to improve the performance of a context model, however, the specific technique and parameters that you choose will depend on the characteristic of your dataset and the goals of your model. For example, you may need to experiment with different configurations to find the combination method best for use specific use case. For example, let's say on the Tensorflow website, the Tensorflow website, you can find different. You can go there and learn more about quantization training. For example, if you are you are working on a different project, you can learn for example, different configuration you can use for your project. They also have good examples on the same. Thank you everyone for watching.